Hey everybody, Mr. Kaminsky here, doing this quick video just in case we may or may not be at school on Tuesday and or Wednesday with those abiotic factors of the crazy weather. Enjoy that snow and rain and cold weather if it does occur. I'm doing this video Sunday night. Hopefully people stay warm. Remember, people, pets, pipes, plants. There's one more. People, plants, pets, pipes. That sounds good enough. Make sure you take care of the peas. All right, I'm going to show you exactly what to do in your lab. Okay, in this lab, it's going to be a natural selection simulation. We're going to be mimicking a predator attacking a prey, and they're going to be mice at this rate. Let's read the front together. It says, the speed at which a mouse can run is obviously a trait that has many contributing factors, both genetic and environmental. For the simulation, we're going to ignore all environmental factors and simplify the genetics so only one gene, the mythical run speed gene, contributes. And here are the possible genotypes for the run speed gene. Big R is going to be a very fast runner and will always get away from a predator. Now, heterozygous big R, little r will be pretty fast. They sometimes escape. And those slowpoke little r's, they're very slow and they rarely escape when a predator attacks. Poor little r's. Oop. So, to determine that other factors do play a part in that ability of the mouse to escape, we're going to roll a dice as well. Survival will depend on two things: the R's or genotype, and what you roll, some of the environmental factors. This will be the table that will tell you exactly what happens. So remember, big R is a very fast mice. If you roll a 1 to 5, they're going to escape, and 6, they just got very unlucky and they died. Big R, little r, those average runners, they have a 3 out of 6 type chance of escaping. 1, 2, 3 escape, 4, 5, 6 die. And little r will be sometimes very lucky and one will escape, but the rest will die. So go back to this chart as we do the activity. What you're going to do is, instead of following this, I'm going to show you what to do instead because we might be virtual during it. So you go to wheeldecide.com. Did this in a previous activity. You're going to first make your wheel with a big R and a little r. So go to the bottom here, do big R in one, little r in the other. Click apply wheel changes. You're going to let it spin. You're going to randomize spinner. And we have to get big R here. You do it twice. This is representing each allele for the mom and dad. So the first one we had big R, big R. That's going to go under round 1 genotype for the offspring. I'd write big R, big R. Do that again 2 times, write it under here, and so on. If you get a big R, little r, put the big R first, and it could be big R, big R, big R, little r, or little r, little r. Next, you're going to roll the dice. You're going to make another wheel. You can just use the same one if you wrote all 20 here. And change the numbers from 1 to 6. If you happen to have a dice at home, you could use a dice too. Spin the wheel. Wheel decide. Get it? Wheel. Wheel decide what the number is. And it's a 6. You're going to write that on the next column where it says roll. 6. Roll those 20 times to get the total numbers. Under result, you're going to write as it lived or died. Go back to the front page. It was big R, big R. I have the roll of 6. Even though it's a very fast mouse, it died. I did not try this like 50 takes and see what happened. This is the first take. So anyway, you're going to write die there. Let's say one of them did escape. So let's say it was big R, and it was a 2. There you'd write escape or live. Do that for all 20 generations. You're going to count the total number of big R that survive. So this would count as 2 big R's, okay? Let's say it was a big R, little r, and you rolled a 1. That would live. This you would count 1 big R and count 1 little r. And then if it's little r, and you happen to roll a 1, it would live. There you would count 2 little r's, okay? So what you're going to do in the first round, you're going to write down the number that live or die in the big R's and little r's. When you get to round 2, we're going to use the number of big R's and little r's that survived, okay? So let's say 10 big R's survived round 1 and 5 little r's survived round 1 as well. We're going to do that number. So there were 10 big R's for round 2. I'm just making up data. Let's say 10 big R's survived. So we do 10 of these. And then 7, 8. Oh, all right. So you do 10 big R's like that, and then you'll do 5 little. 7, 8, 9, 10, and then just 1, 2, 3, 4, 5 little. Again, use the number that you got for round 1. Flywheel changes, spin again. And this will go into round 2 genotypes, okay? Obviously, there's a better chance for the big R's to come up. That had to be little r, spin again. And here we got a big R. Into round 2, you'd write big R first, little r. The same roll of the dice, same live or die, just like we did in round 1. And then the new ones that lived, do one more spin in round 3, okay? So you're always using the previous number of big and little r's depending on the previous round. Final data table. You're going to write the number of big R, not money, number of little r that survived, and the ratio. Just write the total number of big R that survived, a colon, total number of little r's, okay? And then there's questions that go along with it. All right, so again, I'm not sure if we're meeting or not on Tuesday and or Wednesday, so I'm doing this video on Sunday night in case we need it. I'm going to post it on Google Classroom. Even if we do meet, those of you that are virtual could definitely watch this video and understand what to do. Ask questions, obviously, if you are stuck, okay? And good luck. Let the mice survive and not die with the predators.